All right. Hi, everyone, and thank you so much for joining Atrion's webinar with Infoblox. My name is Victoria. I'm the marketing coordinator with Atrion Communications, and we're going to get started right now. Just a quick note before we do, you will see at the bottom left of the meeting window that you're able to seamlessly navigate between the content stage, which is the presentation, and the Q&A tabs. We will be holding off on answering all questions until the end of the webinar. So as you will want to view the presentation and the demo, if something does come to mind, please feel free to switch over and either just enter it into the question box at any point. But we will answer it at the end. So to kick us off now, I'm going to introduce Dom Grillo. He is the Executive VP at Atrion Communications to say a few words and take us into the presentation. Thank you so much.
Thanks, Victoria. This is Dominic Grillo, Executive VP with Atrion. Welcome to our Infoblox Active Trust Security webinar. This is part of Atrion's ongoing webinar series, just trying to educate our customers about different solutions and different ideas out in the marketplace today. So we really thank you for joining us during this session, and again, continue to look out for future sessions that we'll be holding. And with that, I'm going to turn it over to Jim Zilnowski. He's a local channel SE for Infoblox, has been in the industry for a very long time and has got a lot of experience. He's going to go through a really nice security presentation for you, as well as one of Atrion's engineers, Dave Ware, to do a little technical demonstration of what we're showing off in terms of how to stop and prevent DNS data exfiltration.
Thanks, Tom. I had set up a little agenda so you have an idea what we're going to talk about today. Start off with really talking about why DNS is really such a vulnerable protocol, and the solution that the industry came up with to try to mitigate problems with that protocol, which is our response policy zone and the database that is associated with that, which is our Infoblox Active Trust. We'll talk about something that is very difficult to stop, and Infoblox came up with a quite unique solution to deal with that, and that's DNS data exfiltration. And David Ware will then jump in at that point and do a demonstration of data exfiltration using DNS protocol. We'll then talk about how we can protect users anywhere, both on-prem and off-prem, against data exfiltration and malware that uses DNS protocol, which is our Infoblox Active Trust cloud solution, and then next steps that you can take. So with that, we'll kind of delve right into it. Talk about why DNS is such a problem. Well, the one thing is that DNS needs to be everywhere. It's required to resolve pretty much every single application there is out there in all types of business. So it is a major target because it never was designed to have high security functionality within the protocol. It was designed as a hierarchical open protocol, and some even consider it to be somewhat still in a beta format. So because of that, it's easy to work around. And as you can see from Cisco's 2016 annual security report, 91% of the malware uses DNS to carry campaigns. To kind of further show that this is a major problem is the SANS Institute does a lot of research, and what they did is they did a study about a year and a half ago where they wanted to get samples from all sectors within business, education, energy, business, finance, manufacturing, and what they asked for is pieces of malware in a packet capture format, so they could analyze the first 60 seconds of that malware to determine what its characteristics were. And not surprising, as you can see here, that the major protocols we normally would see, things like HTTP and NetBIOS name server, fairly number of packets captures in the first 60 seconds had those types of communications in it. But you can see the top protocol of the 16,000 samples 15,000 samples of those in the first 60 seconds was using DNS. And this makes quite sense because the utilization of DNS allows them to maliciously connect to their home network resource out in the internet and to use techniques that can fool or make it impossible for traditional firewalls, which would work off of IP address blocking and maybe specific port numbers to not be able to track the connections that they make to those websites. So they'll use a technique called fast fluxing. And fast flux networking is they'll change the IP address of that domain and in such a quick period that it's almost impossible to kind of stay in step with it. So this is one of the reasons why DNS was utilized by malware. As a matter of fact, it's utilized in all stages of malware infection and exfiltration. We know that it uses penetration through text records and a number of other techniques to move down through DNS servers into an infected host inside an enterprise, that once it actually can make a connection from an infected host out to the internet, it'll use that to do command and control in the continuing infection stage with additional scripting. And once they actually recover some type of information that is of value, what they'll do is they'll use that for exfiltrating that data through DNS protocol through the DNS servers. Now, if you look at traditional security, next generation firewalls are designed for specific functionality. They have a lot of very good features, IDS, IPS systems, and these are really have more general traffic inspection as it relates to the protocol we're really talking about, which is DNS. Secure web gateways don't really focus much on anything other than URL filtering. Email gateways are looking at email monitoring. So there really is a need for a special purpose solution that really today lacks the ability to do a deep packet inspection within a DNS packet beyond, is it look like a good size packet? Is it UDP port 54, TCP port 54, which is what DNS is? That's about as deep as most of those techniques get, and this is why the industry felt that there had to be some type of special purpose solution. So what they came up with is a policy zone, because DNS servers work off of zones to resolve data. So they came up with a response policy zone, and they abbreviated RPZ. And to give you an idea how it kind of works, just quickly run through just to create a level playing field for people that just haven't reviewed their DNS. Let's say Anne here is on her PC, and she's what we refer to as a stub resolver. So she wants to go to Infoblox.com. So she sends out a DNS query, UDP port 53 out. It'll default to the local recursive DNS server that's defined in her DHCP address scheme that she got. And what this will do is this will actually have to do the lookup, the resolution. So not being authoritative for Infoblox.com, because she's an ABC company and not an Infoblox, we have to go out through the internet to a root server to actually go through hierarchical lookup for resolution. So the firewall just looks at the UDP port 53 packet. A packet is returned as an answer and telling the internal recursive name server within your enterprise to go to .com. .com says, I have a registry for Infoblox.com. Its name server is this IP address in the internet. So the recursive server inside the enterprise then contacts the Infoblox com server, which says, okay, for the www.infoblox.com Apex record, that's an A record with a 54.235 blah blah address here, and that gets returned back to the client so the browser can resolve to infoblox.com. So you can see there's a lot of open communications constantly, and this is just one connection to resolve. Many applications have lots and lots of connections for every keystroke that goes, and you can think of thousands and thousands of these that are going through your firewall at any given time. So it is a little easy to actually communicate to sites that aren't on any type of listing that can be blocked in a firewall. So a lot of next generation firewalls, you can put some type of blacklist functionality you can either add in or add it through a feed. But we feel that in the industry that the best place to actually put that blocking feed is in the recursive server that's doing the lookup. We're in the path in line within the lookup. So this is really where response policy zone resides. It gets a list of domains and IP addresses zone transferred using TCP zone transfer protocol down through your firewall to the recursive server. Excuse me. But really, this function is only as good as the intel that actually comes from the database that's creating this feed. This is one of the reasons why Infoblox wanted to invest in a high-quality threat intel company over a year ago, a little over a year ago, to actually obtain that information and to curate that information as best as possible to feed into our DNS servers and place it in the response policy zone. Obviously, any hits that you have to do blocking against a bad domain that, let's say infoblox.com was in a list, then you would get a syslog output or an output like API output that would basically indicate the resolver IP, which would be the person doing the lookup along with the domain and IP address of the domain. So the threat intel that Infoblox has created is what we call active trust. And our platform is a cloud-based platform that originally came from IID and was integrated into the Infoblox product category. And it's called our TIDE, our Threat Intelligence Data Exchange. And this is malicious domains and IP addresses that are native threat intel. It's uniquely federated platform, and it's curated shared data with a number of industries around the country and throughout the intel community. We have about 150 customers currently, mostly civilian federal agencies, financial organizations, and internet companies. And to give you an idea of the value of this threat intel is that Infoblox's IID Active Trust is the information sharing analysis core of the homeland security connections between major sectors such as energy, oil and gas, education, business, financial, and other types of government entities that feed this database. And then that database is used by more than up to about 100 civilian agencies, federal civilian agencies, as part of the Department of Homeland Security's cybersecurity infrastructure. So it is very high quality data. And to give you an idea, the feeds that you can choose is we have a standard set of feeds that'll do APT botnet compromised domains. We have another feed that does anti-malware. We look at all the ransomware domains and IPs that are out there, and we categorize them. If they seem to be a significant problem or concern in your company, you can load that feed. And then bogons are IP addresses that really haven't been assigned, and there's reserved spaces that sometimes are used, and we can block those also. So anybody that's using RPZ can choose to download any of these feeds or all of these feeds. We have additional feeds in our advanced offering, and these will do additional anti-malware, bot IP. Specifically, we have one for exploit kits, malware DGAs. What's interesting about DGAs are they've been around for a while, and they've actually created a lot of problems, and they're being used in a lot of malware. What is a DGA? A DGA is a domain generated algorithm, and it's an algorithm that basically generates a lot of bogus domains, thousands of domains that don't exist. And the idea is to fool security people from knowing which is the actual domain that will be stood up on the internet for about an hour or two on a specific day at a specific time, and that would be when you would get a command and control or an exfiltration of some data. So the idea is like a needle in a haystack. Is security is going to have a difficult time figuring out which is the bad domain versus all these other bogus domains. So what this actually does, this feed does, is we've already pre-generated the algorithm, the variables to know what these DGAs are actually looking like, and then we can actually begin to block them and alert on them, and then the actual one that would pop in there would actually be blocked also. So it's a nice form of automation to try to let DNS security actually take care of that situation and alert you on it. There's a Tor exit, from the Onion network, where we can block. Then there's we have some Serval domain feeds and a fresh domain from Serval, which is new things that pop up on the internet that haven't been actually determined to go into a specific feed. Because mostly when something new pops up, you want to grab it, you're not quite sure what it is, and then eventually within a few hours or within a day, it's going to get put into a specific feed of one of these other categories. So to give you an idea of what we're talking about here is, this is the record count that actually gets downloaded for any of these feeds, the 4 standard feeds and the advanced feeds, and you can see the DGA is almost 2 million records that get downloaded. And the new domains, well, these vary quite a lot, but they can be up to 2 million records. But you're really talking about roughly anywhere from 4.5 to 5 million records that get downloaded. Now, I can tell you that a lot of firewalls out there that have reputational feeds that can get loaded into them are somewhere on the order of about 100,000 to 200,000 in capacity of records that they can hold, because they're trying to do so many other things with that firewall. Remember, general purpose got a lot of other things that they actually want to do with it. So the actual DNS server is an excellent place to do this, because the record count can be handled. We can look at every single DNS query and compare it to everything on these lists very quickly, and it really is the point solution that you should consider when you're looking at trying to block as much as possible as it relates to this. So active trust, and just a brief summary is that it is acquired curated threat intel from external and internal sources, and then we can selectively distribute it in a number of different manners. RPZ is the one for our DNS servers. We do have the ability to actually export this in other formats like CSV and JSON and so forth. There's a quick lookup indicator for context. So, in a future, webinar, maybe we'll be able to demonstrate, our dossier function to save time and being able to determine how serious an indicator is. And and this is easy to deploy because it's cloud-based throughout your entire enterprise. Now, reputational is only as good as what you know. Problem is what you don't know is really where we're having some problems in the industry, and that is the culprit for DNS exfiltration. That data exfiltration is you can see from these percentages that 43 respondents have indicated they've experienced some DNS data exfiltration problems. That's only the companies that actually reported in these studies. And the reason is because it actually is quite easy to do from a malware program. There's some examples of some of this malware in the last bullet, also referred to as DNS tunneling. And the difference is that with some of the sophisticated firewalls out there, you don't have a signature with this type of DNS tunneling. So you can't pre-program your firewall to look for it. So what Infoblox did is they spent a couple years looking at all types of DNS queries on the internet, and they came up with some algorithms and worked on them in conjunction with Georgia Tech University and some academics in there, and we came up with some patent-pending techniques. And what are we talking about here? We're talking about files that would, let's say, a SQL file or some kind of file that contains valuable information to the internet people. And what they'll do is they'll break this up into chunks. So they'll take the chunks of data, and they'll do is they'll prepend them as a host subdomain, or embed them in text records. And they take that chunks of data and they actually send it through the DNS server, out through the firewall, out into the internet, to, in this example here, to, let's say, serverthief.com is the command and control server. And when it begins to receive the segments, it gets to reassemble those. Now, this is in clear text, but the reality is they're probably going to encrypt the data in some format and reconstruct it at the other end. To give you a kind of like a visual of this, this is examples of encrypted data that's been prepended to a domain name, which is any1.com. So each one of these is a DNS query, which would contain specific chunks of information that's been maybe encrypted with base 32, base 64 encryption, and then broken into chunks and sent as individual queries in various sequences and lengths and time to the command and control server, to show you that it's so difficult to do from a machine point of view, as these are examples on the bottom of good queries and queries that are used by companies to actually do just keep alives. And it's interesting that DNS has been used for quite a while to just say, hey, is stuff still working inside somebody's network, or to get a status, So you can see here, like from the third one, this one for URL esoft.com has got a very large subdomain sequence. So as from a machine's point of view, is how do you tell the difference between what's up on top, which is data exfiltrated, versus what's not on the bottom, which is actual valid data using DNS protocol. So this was the problem. So the database we have is great, and you need it for defined domains and IPs, the Active Trust database using RPZ. But what we wanted to do is in the RPZ recursive servers, create a new licensed software that we call Thread Insight. And what Thread Insight does is it is all this research done that we did to learn and add subdomains into local RPZs, a zone, with an action policy. And that action policy could be to block, to log only, to redirect the user to another IP, such as a captive portal or a trap. And that's really how it works. So if you say this example, now there's some malware on a machine that's trying to go, I steal your data all day, is the data they're stealing, to infoblox.com, you want to stop this from continuing out through the DNS server. And the way you would do it is you'd learn that over a period of time, that domain, each one of those queries is not valid, that it actually is some type of data being stolen. And you want to, in this case, say in an NX domain saying it doesn't exist, you block the communications from continuing on to the Infoblox server, and then you notify the SIM, the subdomain that's getting used to steal data, and the IP of the actual resolver, which would be her PC. So how does it do this? Again, it's a form of algorithms, and it's all automatic. There's no tuning necessary. It uses techniques like entropy and lexical analysis and n-gram analysis. And what it does is it looks at the payload. It looks at that host name subdomain on the front end of a domain. It looks at text records. It looks at the A records, the quad A's of its IPv6, and then it uses those sophisticated algorithms to make some decisions to say, hey, is the packet got too much data? Let me add a score. How frequently am I going to a specific domain? Is it encrypted? Does it look like it's being encrypted with a encryption format? Or is it in English or French or some other language? In that case, I subtract score. So the idea is that you begin to add score over time, and then you adjust your scoring, and then at some point you make a final classification, and you say this is exfiltrated data or not. And then when you do, you actually then place that full subdomain into a special RPZ zone where you then apply the policy of either blocking, logging, or redirecting the user or the IP address. So what's interesting here is that with reputational lists that you block a domain, and with this data exfiltration algorithms, we blocked only the specific subdomain that is actually associated with stealing that data. So one of the things that malware does is they embed themselves into domains that are used for a lot of valid reasons and a lot of applications. So they create a pretty sizable subdomain length where they then prepend the data onto that, and we can actually lock into just that subdomain and not block the entire domain itself. So with that, I want to turn it over to Dave so he can actually show you how this actually is done, how you steal data. Take it away, Dave.
All right, thanks, Jim. Yeah, so let me share my screen here, and then I will show you guys. No, show this one. I will show you how this exact process would actually work. So this is the Infoblox Dex portal, right? It's you guys will all get a copy of access to this. We'll all create ones after the webinar, and you can actually test this out and see whether your network is vulnerable to data exfiltration. Obviously, it's all in Infoblox's portal, and so don't send proprietary information and that kind of stuff. But at the same time, it's confidential with Infoblox and us, so it won't actually go anywhere. So this kind of shows you how the whole process works. So a client will get infected, right? Whether through phishing scheme, they clicked on a bad link, whatever it may be, or it could be a rogue employee even that just decided that they don't like the company anymore and they want to send data outward to be used later. The endpoint will get infected. From there, if it's malware, it'll actually start searching the network for data that is valuable or anything at all in that case, because malware doesn't know what's going to be vulnerable, what's going to be valuable or not. And what it's going to do is it's going to take it and it's going to basically create a hex of it or encrypt it in different methods and make NS lookups or DNS requests for that subdomain that Jim was talking about. When that request gets out to that target server, it now has this hex here, and it can actually reconstruct the files on the back end. From the client's perspective, the the DNS requests will all happen in the background, so a user wouldn't actually see anything. And if you were to run this in a terminal, you would actually see that you actually don't get a response from the DNS server. So that's kind of a big piece of this, is that you don't have to get a valid DNS response to make this work. You just have to make the DNS request, and now you've sent the data off on its own. So this is the portal. When you guys get your logins, this will be the portal you'll see. From here, it would ask you to click on the terms and conditions. You click on terms and conditions here. At the very bottom, you'll be able to click the accept button once you've read all of this, and then it'll open up these two tabs for you. So what I'm going to show you really quickly is basically how this would happen. So what I have here is I actually have an Excel document. In this case, it's the name, email address, passwords, and birthdays of a whole lot of famous people: Winston Churchill, Manny Ramirez, Nicole Kidman, and Johnny Depp, among others. But this is all their logins. We don't necessarily know what they are, but for their whatever company this would have. So what I can do is I can actually, on this portal, I can actually use this Hexify tool. What this will do, and you'll get to see it in action, is it will take this file, and as I click transfer, you see the DNS requests going outbound here, and you see this subdomain of xr0s10.hex. Etc. All of these are DNS requests that are being sent out on my machine at this moment in time. If I was to go here and look, you can see this is the back end. So this is the hacker's DNS server. From here, I can actually click on this, download this file, and I'm actually able to pull a portion of the file. So the thing about this is that I don't even have to have the full length. I just have to have a part of it to be able to reconstruct some of the data. So once this updates here, so this is done. So you can actually see I actually sent out 220 chunks and none were lost. So we're looking at what the hacker's DNS server would have accomplished on the end. So once this will update, all right, 220. So now that it's completely done, I'll download it again, and we'll open it up and just show that I've actually, through DNS queries, not even valid DNS queries, just the query themselves, I've actually reconstructed this whole Excel sheet. If this was proprietary information, let's say Coca-Cola's recipe, I could now have the entire recipe and nothing would have stopped me from doing it because it's literally just DNS queries. What Infoblox does, and I'll show you here, if I change my DNS settings, right now I'm just pointed to a standard Windows DNS, pretty much out of the box DNS setup. So typical for a normal environment. Let me make sure that's right. Yep, 55. Yep, 55. So I'll change my DNS to here now, and you'll see I'll do the same exact process again. This time I'm actually pointed at an Infoblox DNS appliance that I've set up with the threat intel enabled with an RPZ zone. So I've got this RPZ zone here that's basically just says bad domains, and anything that is caught based off of those algorithms that Jim just talked about will get caught. So I'll do this again. We'll send the same file out over again, account information, and this time we'll send it. And you'll see as it goes through, so it's still going, you'll still see the DNS requests going out, right? So my, make sure that, yep. So you'll see the DNS requests going out. So you see 50 chunks have been received. And we'll give it a second to update. But what will have happened here is within the 50 DNS requests, the Infoblox DNS appliance with the threat intel would have actually stopped it, realized that this is not normal behavior of a user. It shouldn't be sending out that many DNS requests. This doesn't look like a valid DNS server, those kind of things. But you'll see I lost 170 chunks of 220. So these 50 are the only ones that it was able to receive. So if I actually go in here and I actually try to pull this one out, I likely won't have much information, if any at all. So like a 23 versus 100 and something, or I think it was 200 that were on there originally. If this was anything bigger, like a database file or like that, it wouldn't have even gotten that information. Even pictures and things get usually stopped immediately. So if you look at actually on the Infoblox side, if I go into this domain aspect, you'll see here, we'll compare this. This domain you'll see was XUC 90 ends in DNS, 8982 AE 7BC. You can see this here, and you'll actually see where it was actually set up right here as a block domain. So you can see how having this threat intel on your network can actually mitigate that damage done. The thing with these is that even in the network that I'm on, I'm behind a UTM firewall that actually has IPS and things on, but it's not going to look for that, and DLP is not going to look for DNS requests anyway. This really is purpose built for this type of attack that is pretty easy to evade normal network protections. So with that, I can send it back to Jim for the rest.
Thanks, Dave. Okay. Trying to get back to my webinar here. We go. Sorry. Here we go. Sorry for the delay. So what Dave actually showed was actually stealing data through DNS, which is why we do the terms and conditions, because when you get a URL invite to do this, you and your security people can actually, from any mechanism, shell script or using a HTML page to our DEX website to steal any type of data through DNS queries. Now, Dave showed some of it getting through, but reality is most of the time they're going to encrypt that with some type of encryption method, which means any blocking, after learning maybe 50 or 60 of the queries are the classification of making it data exfiltration, that you're going to block. So that means the whole file is going to be corrupted. So it actually does help in that area. So what should be your course of action? Well, something is better than nothing, and as Gardner even said in this 2016 study, addressing priorities does not mean striving for perfection, but rather ensuring, or at least that critical exposures are remedied. And I think, and most people that do this view this as a critical exposure within your network. So, would it be interesting if implementing a solution without affecting your current DNS infrastructure would be a good consideration? Because now you really wouldn't have to look at changing out a lot of DNS servers. In addition, if you had a lot of remote users that are actually accessing corporate resources through working at home telecommuting or through other public areas and Wi-Fi systems, and you're not forcing them to use a VPN for everything. In other words, they're split tunnel. They can actually VPN into the 10.net network for that, but they can go out to the internet using the local Panera Bread or Starbucks network. That is a really good thing to answer this question that we're going to offer a solution next for. And then any remote offices that only have a basic router, firewall, with not a lot of protection, and they don't use the corporate WAN would also fit into that category. And what is that? That's really our active trust cloud. So everything we talked about till now, the RPZ reputational feed of 5 million, roughly 5 million indicators that we're checking against bad malicious domains and IP addresses, And the data exfiltration protection is available anywhere on-premise or roaming from any remote office. And to give you an idea of how that might look look at this picture here. We've actually taken all our technology and put it into a cloud service with an Anycast address that's available throughout the world. So you could take on-premise solutions that have your current DNS infrastructure that's in place, but all you're doing is, rather than sending your DNS queries to the ISP that's connected to that premise location, you would redefine to send those DNS queries out to our Anycast IP address at the cloud. And in doing so, you would then run every single DNS query through the cloud data exfiltration protection, and then run through all the reputational lists and allow yourself to set up policies to either log only, block, or redirect, just like I talked about with the RPZ zone. So we took in all of RPZ, including data exfiltration, and put it in the cloud. Now, for off-premise users, we're really talking about a client, because one of the things you got to get through is you got to get through captive portals a lot of times. You have NATed addresses. We don't know what network you're coming from, so we have Windows and iOS clients that will automatically, once connecting or pinging to the Anycast address, would encrypt and pass only the DNS queries up through to the cloud for resolution, so that you would look for data exfiltration from the PC or remote device and actually going through the reputational list. Now, the thing that's unique about this is we've now tried to combine both. So as a customer, if you are using Infoblox's technology or want to use our technology closer to get the client IP within the premise, and you want to combine security reports, we have the ability to combine both off-premise and on-premise information to give that deep reporting and analytics information to know the MAC address, the device type, the lease history, the IP address of what's on-prem, and then what remote clients are doing. So we do combine both our internal RPZ analytics solution along with the cloud-based solution with this solution. So in summary, Active Trust Cloud allows you to protect your on-premise roaming clients, remote locations against data exfiltration and malware by using reputational comparison lists. And then you can provide the flexibility of deploying this pretty much as an OpEx model, and then it gives you that visibility of your devices both on-prem and off-prem. And we do have a 30-day trial service, so Atrion can work with you to test this out. So you wouldn't even have to data exfiltration actually put equipment on site. You could just sign up for a 30-day eval. You could use the DEX data exfiltration website to see how well and effective it works at blocking data exfiltration and the reputational list against bad domains or various different types of ransomware and exploits and so forth. So with that, I'm going to really just kind of open it up for questions now, and